Agent AI versus bot AI. You know, AI son versus thought daughter. Quinn versus Claude. True. Yeah, Quinn versus Claude, man. I think I've never used Quinn, so Claude wins. Cool. Beer time and sandbox time. hacking guide, testing guide, development tools, written documentation, license rules, subsystem, quick contents development, prod patches, code of contact, the Linux kernel. Ooh. gvisor. But you can, I think you can run gvisor, if I'm not mistaken, on Fedora. SY debox. And then GitHub. You could. It is possible. Yes, this is the one. The CV 2026-34078, complete sandbox escaping, leading to host file access and code execution. Very critical. We will look over that. First, we'll look over that. Flat kill is somewhat outdated. What's a I wonder if Flatpak. Let's see. So it seems like Flatpak has a critical security vulnerability of 2026. 34078, a complete sandbox escape leading to the host file access and code execution in the host context. This is why relatively it is always advised to do virtual machines, because virtual machine escaping is much more rare and much more complicated to do, because it actually separates, I believe, from the host. But we'll look into that. VM versus container. And there are some solutions to the container ecosystem that I am aware of. Something as cool as gvisor. Gvisor takes container security to the next level. I believe that there's some other products out there that do exist where it solves this container security issue, which is pretty based. We're going to look at container versus VM similarities, differences from Red Hat themselves. Red Hat, surprisingly, just Fedora in general, has relatively a good track record for security in general. In perspective. Cancel. Boo! And this does matter to a certain degree, because if your security is lacklustering inside your system, it is much more difficult to obtain a higher level of OPSEC, because hence, like say you have some secret files on your computer, those files maybe have personal information or whatever that might leak to who you are, or it might leak stuff that you don't want to be leaked that could do some correlation, maybe some metadata, etc., etc. I mean, it's just a common practice for people to always say security and privacy are two separate things. I just disagree with that when you look at it from the whole. If you don't have good security, you relatively cannot have good privacy. It's like, think of it like I'm going to use the house method. We all have blinds, locks, and doors on our house. That safeguards our privacy in perspective and in hindsight, and pretty much like view in general. If I remove the doors, the locks, the blinds, and everything, I should just have no expectation of privacy. It's a very simple analogy, and it's maybe a simple oversimplification how it works. But if we do not have good secure platforms, good security measures, you essentially cannot have privacy. It's just not possible. Even faking information is a security measure. You are not revealing the real information of who you are, so you relatively don't have to worry about it leaking because it is not real information, and you might even, in some cases, want it to leak, so it gives false flags. But in reality, the average person isn't going to sit there and fake everything throughout their entire life. You have to live in society, and if you live in America, if you get a loan, if you not even just get a loan, if you have a W-2, if you have a job, you're going to have things that are going to be tied to your real identity. And how you mitigate that is, in perspective is a more complicated answer because everyone's threat model is different. But in the grand scheme of things, if you're using products that do not have good safeguards or security, you are then being put at more of a risk because you have more exposure. I mean, it's just simple, OPSEC 101. Have good security, have tight security. The likelihood of a data breach or a leak that is too revealing probably will and should not exist. So it's one less threat to really worry about. People can argue in the comments below or later whatever they think. That's the point of an opinion, is everyone can have one. It doesn't mean it's right. I think this is a very back and forth topic. This is why I run CubesOS on my laptop, because CubesOS provides strong isolation through the virtual machine management, and Zen Hypervisor is relatively a very good, solid security product in itself. The CubesOS team kind of like takes it on themselves to do a lot of the patching and the work beyond what comes natively with the Zen project in general. So it's something to think about. You are now increasing your security, which in theory would end separation, and you're isolating stuff from each other. You're essentially increasing your privacy. This is even with when you use Tails, you should only use it for one use. Like if you're logging into your email, you should use Tails to only log into that email, unplug it, and then plug it back in, and then do the second option. Quiet nerd. That's what a virgin would say. So thank you. I appreciate what's going on. The Icon 2026. So we're going to look at the sandboxing escape leading host file access. Every Flatpak app is able to read and write arbitrary files on the host and execute the code in the host context. This was brought up pretty much just a couple days ago. The Flatpak portal accepts paths to the sandbox expose option, which can be app controlled sys links, sysm links pointing to the arbitrary paths. Flatpak run mounts the resolved host path to the sandbox. This gives apps access to all the host files, and this can be used as a primitive gain-to-code execution on the host context. This use has been patched in version 1.64 and will be patched in the upcoming version 1.18.0.1. Mitigations: disabling the Flatpak portal mitigations the issue, but they can result in misbehaving apps. Sudo syscom tac global mask Flatpak portal service system kernel user stop Flatpak portal service. The fuck? That's why I hate the internet. So, if you're running Flatpaks in your system, you should probably not right now, or at least wait till the update comes through. Speaking of that, I need to update my system. I always forget to. But that's the great thing about Linux, you can do it live. And remember, don't forget to do TAC-Y to save yourself millions of hours every year. So we're going to now look at the containers versus VMs, their similarities, the differences, the combined approaches. They definitely do exist. Containers and virtual machines are different approaches to the packaging computing components and isolating them from the rest of the system. The main difference lies in what components are isolated, which in turn affects the scale of portability of each approach. Most of the time, most people pick containers in in a lot of environments because they use a fraction of resources. And if you even look at Proxmox has container LXCs and VMs, obviously. But if you look at the options you have, you can create a CT, which is a container, and you can actually do nested virtualization, which is kind of insane, and it's kind of cool. Nesting allows you to run like Docker inside here, like a container inside a container, which is pretty based. So it's definitely an option. When look at OpenVZ, I will. Damn it. OpenVZ. I think it's definitely one of those things that it's kind of like one of those things that is something that I think people don't think about, especially a lot of people run Docker. A lot of people run Docker like on their host machine. They just set and forget it. They do nothing, no further thinking. But there's definitely ways to lock down your container security. OpenVZ allows multiple secure, isolated Linux containers, also known as virtual private servers or virtual environments, to run on a single physical server. This technology enhances server utilization and ensures that applications do not conflict with each other. Oh, it's kind of like multi-tenanted. How about sandbox beer in your liver? I do. My liver does a great job at it. Hopefully. Wow. High performance, each container performs and executes exactly like a standalone server, delivering near native performance for your applications. Independent operation, containers can be rebooted independently and have their own root access. User IP addresses, memory process, efficient resource utilization, scalability, security. Maintain strong isolation between containers, ensuring that each environment is secure, operates independently. Wow, very based actually. Thank you, the Icon 2020. Super cool. This is very sick. So it's like multi-tenancy. Bare metal installation. OpenVZ builds its own Linux distribution with both hypervisor and container virtualization. It's based on its own Linux distribution with the additions of its own custom kernel. OpenVZ management utilities are QEMU and Virtuoso installer. It's highly recommended you use OpenVZ containers in a virtual machine with this virtual installation image. See virtual download installation. Okay. Using virtuals in the Vagrant box. The Vagrant is a tool for creating reproducible and portable development environments, easy to run environment. Oh, nice. Wow, this is very cool. OS templates, latest news, recent changes. Oh, okay. Going early today. See you later, Billy. No CentOS or Debian. Good. No Debian. Bad no CentOS. But CentOS is like, So, both containerization and virtualization are mature, well-supported IT technologies. They can work together in many architectures, serving different application needs. Modern applications perform, including Red Hat OpenShift, supports both these technologies and encourage their flexibility. OpenShift is pretty cool. I set up OpenShift once, but it's very heavy. It's a very heavy thing to run. A container is a unit of software that holds together all the components and functionalities needed for an application to run. Unlike a virtual machine, a container doesn't require a guest operating system. Most modern applications are made of multiple containers that each perform specific function. Like you can run, a container for your database, a container for this, a container for that, at a fraction of the resource. I mean, you can run 3 containers to achieve one thing. A container packages an application and dependencies together in a portable unit. You can deploy that container anywhere needed, a developer laptop, data center, cloud environment, or the edge, with the expectation that will maintain consistent behavior functionality because it's, low resource model and it's high availability that it can achieve, especially if you get into clustering with Kubernetes, or you do use Portainer or Docker or whatever. Or Swarm. Docker Swarm, I think, is still relevant in 2026. I don't know. So, containers, compared to VMs, containers are typically smaller, measured by the megabytes. The smaller size makes them faster and more agile in a way to scale to match demand. With their portability and consistency, containers are important to modern cloud-native software development, including DevOps and CI/CD practices. With containers, different teams can work on individual parts of the application. We know what a virtual machine is. A VM is an isolated computing environment of its own CPU, memory, and network interface storage. An operating system. Emulating a physical computer, multiple VMs can run on a single server with a hypervisor acting as a lightweight software layer positioned between the physical host and the virtual machines, aka Proxmox. You can actually run full desktops in Proxmox. It's pretty cool. Or there's Chasm. Chasm is like a way to have a virtualized workspace. Chasm is a very interesting, cool platform to use. I have used it, but I just have no need for it. But it's cool. And there's, I mean, tons of options. BirdNet. Let's see. I should do that one. But it's definitely one of those options that you have when it comes to virtual machine management, containers and VMs together, using containers to unlock the advantage of cloud-native applications, including scalability. What if you could manage VMs the same way? Open source projects like KubeVirt makes it possible to run VMs side by side with containers. You can apply a consistent set of modern tools. Never heard of KubeVirt. It's kind of cool. Scalability, run VMs across different infrastructures, including in on-premise cloud and edge environments. Mitigate your VMs, maintain your moment. There's tons of options out there, and usability in hindsight. But you could go deep into the weeds and the differences between containerization, the pros, the cons. Not really a not really a big, not really a big, learning moment to know at the weeds of it, but it's definitely pretty sick that we have, the pros and cons of both in hindsight. See. Cool. So, Landlock is kind of like an interesting addition to Linux. I mean, Linux, as we know, has not been the most secure in recent years. In general, it was never really built with security in mind. I know people argue that to death. I've always been a Linux user for the free and open source part. Not free as in cost, but free as in freedom. But I would like security to get integrated into the Linux system just so that people don't have to worry about making big oopsie daisies. So the goal of Landlock is to enable restriction ambient rights, e.g., example is global file system or network access for a set of processes because Landlock is stackable. LSM, a stackable LSM. It makes it possible to create a safe security sandbox as a new security layer in addition to the existing system. Wide access control. This kind of sandbox is expected to help mitigate the security impact of bugs or unexpected malicious behaviors in the user space applications, one of the biggest problems in Linux, to be honest. Landlock empowers any process, including unprivileged ones, to securely restrict themselves. We can quickly make sure that Landlock is enabled by running the system looking for Landlock up and running in kernel logs as root. You can do d message grep landlock journal ctl kb g landlock. Developers can also easily check for landlock support with a related system call. If landlock is not currently supported, we need to configure the kernel appropriately. Landlock rules. A landlock rule describes the action of an object, the process intended to the platform. A set of rules is aggregated in a rule set, which can be restricted and threaded and forced in its future children. I forget that Linux uses the word children. Don't know why. It is kind of funny. And then you have, a lot of systems, like system setting up. Definitely super cool. So, container-wise, we have something called gvisor. It's the container security platform. It's made by Google. gvisor is the missing security layer for running containers efficiently and securely. gvisor provides a strong layer of isolation between running applications and host operating system. It is an application kernel that implements a Linux-like interface, Unix Linux, and is written in memory-safe language Go and runs in user space. gvisor includes an open container innovative. It's an OCI runtime called runsc, and it makes it easy to work with existing container tooling. The runsc runtime integrates with Docker and Kubernetes, making it simple to run sandbox containers. gvisor can be used with Docker, Kubernetes, or directly using runsc. You can use it. You can even run Docker containers on your host system, and it's pretty based. I mean, learning how Docker works is kind of cool, especially if you get into Docker networking. It's its own thing. It's kind of cool. Running a container. Now you run your container using the runsc runtime. Like you do a hello world or whatever it may be. Many Docker options are compatible with gvisor. Try them out, and it's kind of like the best option there. And even OpenVZ, very base, very cool. And that's how relatively containers work. I appreciate everyone stopping by. I'm going to go drink more beer and think about all the other container stuff that I've already forgotten. I'll see you guys in the next video. Don't forget to comment below your favorite container platform. If you don't, you'll have 100